In this video, we're going to go ahead and write the unit tests for the screen class. Remember, the screen class is responsible for writing the gallows. We should actually run Pyland against it first. Oh, we're missing a bunch of stuff. Okay, that should take care of the missing doc strings. But what about this anomalous backslash in string? String constant might be missing an R prefix. In Python, you can do literal strings by using the R in front of the double quotes. So for whatever reason, Python doesn't like using that backslash. Oh, it doesn't like it right here. Well, the solution is to go ahead and stick that R in front of there. And if we do that, we don't need that slash there anymore. To be consistent, we can go ahead and add the R's to the rest of them. All right, let's see how we're doing. Missed a couple trailing white spaces. Again, that won't cause the code not to run, but might as well get in the habit now. It's easy to fix. There's no reason not to. 10 out of 10, we're good to go. So for the test screen, again, we want to make this executable. We want to import unit test. Import that context so that we get the one we want from the repo. We're going to need a mock patch, so let's go ahead and import it. Because we need to be able to test both the NT and the non-NT. So how do we do that? Well, we trick it into thinking that we're either one. We're going to explicitly say, pretend like you are. Now notice I used a decorator here as opposed to the context manager. You can do that in unit tests. There's really no specific reason to do it one way or the other way. Sometimes it can be cumbersome to have a whole bunch of direct decorators in front of your method, but it can also be cumbersome to have a whole bunch of nested contexts as well. Now the command that clears the screen is, OS system. I don't want to actually clear the screen, but I do want to know how it was called. So I'm going to say as mock system so I can reference that later. So clear the screen, which it won't really do, right? It should call this mock, and then check to see if it was called the way we want it to be called. Now here's a little trick. When you're writing unit tests, and you're not 100% sure if you've written them correctly, write them to fail first to make sure. Like this assert called with can be weird to use. I want to make sure that it's being handled correctly. So I'm going to assert that it was called with foo. This test should fail. That way I have a better idea that it's working the way it's supposed to be working. And everyone say it together. It would help if I spelled it correctly. And included a main. Right, it failed. The actual call was CLS, which is what it should be. But now I know that this assert called with method will work for my purposes. Okay, I also want to check to see if it works for a POSIX system. Now we're cooking with gas. The other method we want to test is this gallows method. And if you look at it, and you think about it for a second, what do I really want to test? I want to test that when I pass the number of guesses that I get the correct gallows back. And I want to test that, boy, if I pass an invalid number, I still get the right gallows back. If I didn't have that branch equals true, I wouldn't need to run both tests. But I want to run both tests. It's good to run both tests. So let's do that. So if I look at the gallows method, it actually does a print. It doesn't return a string. I don't want it to print to the screen, so I need to mock that. So basically, call gallows with all the valid indices. And then check to make sure print was called correctly. Again, this is a good example of let's make the test fail first to make sure that the test is sound. Test fails, right? I said it should be foo, and it was actually what it was supposed to be. Now put the correct value in there. And the test should pass. One more test. Check that outside of bounds. So I'm going to just do two tests. I'm going to do a -1, and I'm going to do whatever value is going to be one more than should work, right? Again, let's make it fail to make sure our test is written correctly. Yes. Now, it should default to the last element. For test succeed, let's run it with the coverage. No conflicts, and let's get the report. Dictionary 100%, screen 100%. Test dictionary, 37 exits showing up. Okay, I apologize. I ran into something that I've never seen before, so I had to take a break there and figure out what was going on, why I'm getting this. The test dictionary unit test is not running. It's not executing all the lines. This should not happen. And the problem comes down to this for loop, right? This tells you that it's not going 37 to exit. It's not testing that. And for some reason, it doesn't like this for loop. What's happening here is it iterates through all of the words until it runs out and the last one fails. So it's making it all the way through this range. I'm not 100% sure why this happens, but there's a fix. So let's just create our own copy of the dictionary. And exclude all the words. Now any get should fail the first time. Let's see if that fixes it. All right, one last thing. If you noticed, if you happen to be doing these unit tests yourself, they're actually taking a long time to run. I'm skipping over that in the video, but in the real world, these are taking way too long to run. Unit tests are supposed to be fast. And the reason it's taking a long time is because we're iterating through all of the words in the dictionary. And that's happening in this test get. We don't really need to test all of them. We can test just the first 100. So we can replace that in the setup by changing what the actual underlying words is. We'll say just do the first 1,000. Let's see what kind of impact that has on the times. Now it's running much faster. Tests still succeed, and we're still at 100%. So that's our foray into unit testing. I promise next video we'll start working on that game class.